Okay, hello everybody, and today we are going to be talking about group theory, and especially the axioms of group theory and the fact that we actually can do a little bit better by assuming a bit less as axioms and still get exactly the same results. So let's recall how a group works. So a group is given set G, and we also have a binary operation, which we denote here by a dot. And binary operation, so you can multiply two numbers of G, and you always get actually two elements of the set G, and you also get you always get another element of this set. And then we've got three axioms. We write them like G1, etc. So the very first one is that there exists some element E inside of this this set G, with the property that for a given element A, when we do A times E, that's equal to E times A, and that's equal to A. So E does nothing. Then we have second axiom, and is that if we have some elements A, B, and C inside of the set G, then when we do A times B and then hit it with C, it's exactly the same by first doing B times C and then multiplying by A. And notice here that I left out the dot. And so here are still dots. That's a way of writing this. I have the third axiom, and it says that for each element A, and we have some element A inverse with the property that that A multiplied with A inverse equals A inverse multiplied by A, which equals the identity. And what we're going to show today is that within these three axioms, when we leave out this condition and we leave out this condition, we still get exactly the same results. So if we just assume that there exists an identity element inside of the set G, such that for all A times C equals A, and some equivalent thing for this third axiom, then we can deduce from that for all A, E times A is equal to A, and that the inverse of A times A will be equal to the identity element. So this is what we want to show, and here is our proof. So first of all, so we start by picking pick some element A, and we now want to show these two things. So A is arbitrary. And first of all, because of condition 3, we know that there exists this A inverse with this given property. And so we're going to call it A inverse, and via the first axiom, we know that A inverse multiplied by E will be equal to A inverse. And because we can left multiply by this identity element A. By the way, our result would be trivial if D is abelian. So if multiplication commutes, so then you can just swap the things around in this equation, and you get exactly the results we want. So this proof especially is interesting when we're working over a non-abelian group. Okay, so we have this condition, and it's because of G1. And then we indeed also knew that that A times A inverse was the identity, and it's G3. And then we know this is equal to identity, so we can plug that in up here for E, so we get that A inverse multiplied with A multiplied with A inverse, so that's the identity up here. We substituted this thing for the identity. It was going to be equal to A inverse. And then this really looks like what we want. A inverse times A. It's exactly the thing we need up here. So we like to cancel out this A inverse on both sides. And that we can do by introducing the inverse of A inverse, which of course will be A, but at the moment we don't know. So we're just via the third axiom, we know that there exists some A negative 2. So this is the inverse of A inverse. So and we know that it holds that A inverse times the second inverse of A will be equal to the identity. And then we can right multiply in this equation by the second inverse of A, so we have A to the negative 1 times A times negative A. Then we have the second inverse of A equals first inverse of A times the second inverse of A. And we know this part will be equal to the identity. So that's nice, that's what we wanted. And the same holds up here. So this part is also the identity, so we get A inverse times A times the identity. And of course, we know that when you right multiply by the identity, that's part of the axiom we started with. We know that you get still the same, so we know that A inverse multiplied by A equals to the identity. That's exactly the first thing we wanted to show. Now we have exactly one thing left. We need only to show that now we want to show that E times A, so the identity times still our same given number A will be also equal to A. And to do that, we now know that by the thing we discussed on the last slide, that the identity is equal to A times A inverse. And so now in this equation we're going to right multiply with A. So we get E times A is equal to A times the inverse of A, and here we have, we right multiply it by A. And now this actually is the first time we need the second axiom, the associativity, because we first had A times A inverse, and we can imagine some parentheses around this and then right multiplied by A, but now we're going to change the parentheses to be like this, and of course we know this is the identity. So we now have A times A equals E times A equals A times the identity, and of course by our first axiom we know this equals to A. So this way we have both the conditions that we both the things we wanted to show. And of course you can do it the exact opposite way. So here in the beginning we left out these two. You can do the exact same way, leave out those two, and then construct the same thing. But I think this is a nice result, that we actually don't need all of the assumptions we're making in the beginning of group theory. So that's nice. That's what I wanted to share with you. That was it for today.